Hi and welcome to question 5. We're busy with the Namibian 2012 NSSSCH, the higher level, paper 1. Alright, from November. So question 5, we're asked to simplify the following completely. Let's start with question A. So question A, I'm going to rewrite the whole question in case it might not be as clear on the paper that I copied and pasted here. So we start with 6a squared minus 6 at the top over 6a multiplied by a cubed minus a squared all over a squared minus 2a plus 1. Alright, and now I apologize if my a's look like alphas or 9s or anything. All of these things that look like sort of like a's, they're a's. Okay, so what we want to do if we're simplifying algebraic fractions, we want to factorize every little part that we can, because that'll make our life a lot easier going forward. So first, this top left part. Can we factorize this? Yes, we can take out a common factor of 6. And what's left? We take a 6 out there, a squared. Take a 6 out here, minus 1. Now at the bottom, can we factorize? No, it's already one term, so we just rewrite that. Over here, a cubed minus a squared. Yes, we can take out an a squared. What's left? Take out a squared from here, that's just an a. Take out a squared from here, that just leaves us with minus 1. And at the bottom, the favorite factorization problem, the quadratic trinomial. Now in this video, we're not going to go over how to factorize quadratic trinomials, but I will just factorize it. So quadratic trinomial, we get two brackets. We know the first two things multiplied together must give us the first thing, so that's going to be a times a will give us the a squared. And we know the last thing times the last thing must be equal to this last thing. So in this case, it has to be 1 and 1. But we need to get the middle term of negative 2, so minus 1 will give us negative 2, and then minus 1 times minus 1 will give us plus 1, so we know it will work. Alright, every little part is factorized, except, what can you see? What can we still factorize further from here? That's right, this bracket right here. That's the sneaky one, because we couldn't see it at the start, but after we took out the 6, now we can see that's the difference between two squares. Because a squared can be square rooted perfectly, and so can 1. We can factorize that even further. Now the difference between two squares, we'll get two brackets again. The square root of the first term goes in the first place, and we get a plus and a minus, and the square root of the second term goes in the second place. The square root of 1 is 1. Nice. Again, the rest we can rewrite because they are factorized as far as they can be. A minus 1 over, and then we've got a minus 1 times a minus 1. Now the nice thing here is, multiplying and dividing by algebraic fractions, that's the easy part. Adding and subtracting is where it gets a little bit more involved. So this is nice. Once we have a multiply in here, we can just cancel anything at the top with anything at the bottom. As long as we have one term over one term. And everything is one term over one term, right? Because terms are separated by minuses or pluses, not by multiplication or divisions. Okay, so the 6 cancels out the 6. This a plus 1 doesn't have anything to cancel out with. A minus 1 can cancel out with a minus 1. A squared. One of the a's here, so let's cross that one out. One of those a's can cancel out with that one. And this a minus 1 can cancel out with that a minus 1. So what do we have left? At the top, we've got an a and this bracket. We've got that left. And at the bottom, nothing. So this is our answer, as simple as can be. Perfect. Alright, now we move on to question B. Question B, again, I'm just going to rewrite the whole question so we can see what's happening there. So 5 to the power 2x plus, or 2n plus 1, multiplied, and I'm just going to use a dot for multiplication, dot 3 to the power 2n minus 3. All of that over 15 to the power 2n. Okay, so one of our big friends when it comes to simplifying algebraic fractions, especially if they're exponents, is to use prime factors, to prime factorize every term or every number that we can. So let's start by doing that, and after we've done that, I'm going to do a couple of different methods to solve from there. So our first step is going to be the same regardless of which methods we use. I'm going to keep the 5, that's already a prime number, so I'm going to keep that. Plus 1. 3 is already a prime number, I'm going to keep that. But what about 15? 15 is 3 times 5 in its prime factorization form, to the power 2n. And maybe let's just do on the side a quick recap of what prime factorization is. If I give you the number, let's say, we'll make it 225. We have to figure out what is the prime factorization of that number. Well, we can say, okay, what is the first prime number that can go into 225? Well, 2 won't work, and then we check. Okay, let's use the calculator to check, to show what we'll do in real life. So 225 divided by 2, well, we should know that doesn't work. We see it doesn't work, it doesn't give us a whole number. So let's try 225 divided by 3, the next prime number, 75, perfect. So we can say 3 goes into 225 75 times. Can 3 go into it again? Let's try. Yes, and we get 25. Okay, so 3 can go into it again, we get 25. Can 3 go into that? No. Okay, so let me try. What's the next prime number after 3? 5, right? So 25. 5 can go into 25. Answer is 5, and then we see 5 can go into that again and leave us with 1. So now 225 we say can be rewritten as this: 3 times 3 times 5 times 5. And 3 times 3 is 3 squared, and 5 times 5 is 5 squared. So this is how we do the prime factorization. Now, a lot of you will have calculators that can do this for you without you having to do this ladder method. Right, so if you have, I think almost all Casios can do it, and some of the Sharps can do it as well. If you have anything else, just check if it can. Try to find out. Now, how you would do this, you would type the number. So in your calculator, let's do it steps. Step 1, you would type the number you want to prime factorize. Step 2, you press equals. Step 3, you press second function or shift, depending on what calculator you have, one of those two. And then step 4, I think on the Casios it says something like p fact or just fact. Look for this word. And then your calculator should just give you, if you typed all of this, your calculator should just give you 3 squared times 5 squared. Right, and if you get that, then you know it works. Okay, back to the question at hand. So that's how we got 15 is 3 times 5. So that's prime factorized. Okay, so now, and if we do this from the rules of exponents, we know this 2n can go into both parts there. So maybe let's just do that. Let's just, on this step already, employ that rule. And I'm just going to give a little bit of space. So that's going to be 3 to the power 2n times 5 to the power 2n, right? And this, the original thing was just 5 times 3, or 3 times 5 to the power 2n. So it just went to both things inside. All right, so that's the first part. Prime factorization, very important. Here's a nice little shortcut you can use in your calculator if you don't want to do that ladder method, if you feel it takes too much time maybe. Now option 1. Option 1 for how to move forward. There are many options. I'm just going to do 2. And there's lots of different combinations in between what I'll be doing here. So the one option that a lot of people like is to split up the exponents by unknowns or variables and just numbers. Okay, so that's the first option I'm going to do. I'm going to say 5 to the power 2n plus 1 is the same as 5 to the power 2n times 5 to the power 1. And then the same with the 3's. 3 to the power 2n times 3 to the power negative 3. All over. And then 3 to the power 2n times 5 to the power 2n. Alright. Now once we've done this, we can see if we can try to start cancelling. Because we've just got one term over one term, so we can cancel. 5 to the power 2n, 5 to the power 2n cancel. 3 to the power 2n, 3 to the power 2n, that cancels. So what's left? 5 to the power 1 times 3 to the power negative 3. And now some people might stop at this step, but that will be a problem, right? Because we're not allowed to have negative exponents in our answers. So how do we change the sign of an exponent? Well, we move the term, the thing we have there with the negative exponent. We move that thing to the other side of the line. So at the moment it's on top, because we can say that's the same as over 1, right? So then the 5 is fine, it can stay where it is. This has to move to the bottom now, and then the exponent will change from negative to positive. Okay, and then just write that as 5 over 27. That's our answer. And we also see here that tell us leaving your answer as a common fraction. So that is a common fraction. Now option 2. Option 2 would be you just write the first thing you see, so 5. So you've got 5s and 3s. Those are your numbers you're working with. So we can do 5s, and then all the exponents with 5s at the top, you add. So you've got 2n plus 1. If there was any other 5, let's say there was another 5 to the power 4, then you would add the 4. Right? So you add everything at the top, if there was anything at the top. Then you put a minus sign and everything at the bottom. So the 5 at the bottom just has the 2n. Great. So that's the 5s are covered. Then we do the 3s. Add everything at the top. So we start with the 2n minus 3. Then nothing else at the top, so we don't add anything else. Minus, and then we add everything at the bottom inside this bracket. So there's a 2n, and that's it. Now all we do is we simplify that. So 2n minus 2n cancels out, and then we're left with a 1. 3s, 2n minus 2n cancels out, we're left with a negative 3. And then again, same idea, we just have to take the 3 to the power 3 to the bottom. Well, that's quite ugly. 3 to the power 3. And then 3 to the power 3 is 27. And there is our common fraction final answer. Alright, so if you have any questions or if you have any other methods that you tried, please let me know in the comments below and we can have a discussion about which method works for who, and maybe there are some other shortcut ways or anything else that's interesting. Maybe something that I haven't thought of yet that we can discuss further and that could help everyone else. Thanks for watching, and I'll see you again soon.